Actually, I've got a set, a couple of little pieces that we'll run through here because first one is from 5 years ago, which is a while in IoT time and computer time, but it's kind of fun and introduced a new product. And then I've got one that builds on that, and then another one that builds on that as we can watch the progression over that 5 years. So let me kick that first one off, and if I can manage to do this, I think it should just work great from here. And all right, that's a company called Boston Dynamics. You've probably seen. Oh, hang on. Stop the video. There we go. You guys didn't get that, but I did. Boston Dynamics, they came out with a product 5 years ago now. That was the rollout, hey, you can buy this now thing for a robot called Spot. A couple things to note in there. Obviously, it was fairly good at navigating environments. It was built for some harsh environments. And the big thing that you've got is you've got two access ports in the back that you can attach stuff to and then upload that. So you can outfit this to do a lot of different things. Good in war situations. Great. Yeah, that's if you go to look at that video and then look at the commentary, it's like, you know, yeah, people going, how much freedom can we strap to the back of this thing? Yeah, it's great. It looks like a dog. So that was 5 years ago, about 6 years ago now, actually, probably for the initial rollout. But the initial rollout there, you saw they were focusing on a construction setting. So not surprisingly, a construction company did in fact get one. PCL is one of the large construction companies in Canada. They are based out of Winnipeg, and they bought a Spot. So here's a little blurb about what they did with it.
Clear that both Pomelo and PCL, as general contractors, we're facing the same issues when it comes to integrating technology into the construction industry. So it made sense that we'd share lessons learned, that we'd work together, we'd address these issues together, and we'd come at these issues with a strong, unified message.
So I think this is an interesting time to be in construction with robotics, because it's an industry that typically hasn't digitized, and we can use robotics to complement field workers. So on Spot today, we have sensory from Lighting Tech to measure temperature, humidity, light, and GPS. We've also got a 360-degree photogrammetry camera on there, which helps us measure site progress and quality. In addition to that, we have a Leica scanner on there, which helps us measure quality along the site for concrete pours. So Spot today is doing those three things for us that one single human can't do simultaneously. And so Spot can give us the opportunity to create great efficiencies at the workplace of construction.
One of the main benefits that Spot can show us is how do we autonomously do mundane tasks that are hard to do, tasks that can be in certain spots that are maybe congested or unsafe for a human being to go into, but also just understand what robots can do on a project site.
So we've been using Spot for 2 years now. The first year, there's a lot of debugging, a lot of programming. So there's a lot of working with the different manufacturers of the different payloads to make Spot productive and get it to the point where we are now. The second year has been really exciting, really productive on our site. All the payloads are speaking together, and now we're moving into artificial intelligence and autonomous movement, which is exciting. The sensors that we're using with the JSI platform are going to be used for whether it's GPS, knowing exactly where Spot is and linking some of the other sensors, whether it's temperature, humidity, and making sure that we're gathering data from the job site and able to display that into the JSI platform.
We're tying that information real time back into job site insights on a single pane of glass, along with the other payloads, the 360-degree camera and the Leica scanner, to make it very, very easy for field workers to see on a single screen the information that they need to make quick decisions, understand site progress, where they may have quality issues, defect issues, compare that to schedule. And so rather than going to 3 or 4 different screens to get that information, the single pane of glass really creates a great efficiency for construction. I think robotics will be commonplace in construction in 5 years. This is just one example of a robot that we're experimenting today to figure out and find out how it can advance construction today.
Nolan, did you see their newest robot?
Right, so you can see what we're seeing here then is this idea that we can take some devices, which are those payloads that go on top of Spot, and then float out, hey, what can we do with this? And you can have a bunch of different, in this case, sensors, things that are reading values from the environment. You saw they were using LiDAR, which is a radar type technology, taking camera photographs and things like that. They talked in there again. That is from 3 years ago. So I think you can imagine that as they start to work into, well, if we gave these images or these pictures or something like that to a specifically trained AI, as opposed to a generative AI that's supposed to try and do general intelligence, but actually had one that was optimized for analyzing things about construction sites, all of a sudden you could gain a lot of data by having this robot just go around and grab it periodically and feed it in and get a lot of reporting back about, well, here's what we see in these images. Here's what we see with this data, and you don't have to have some flunky who goes around and gathers it every few hours or every day or every night. When the site clears out, you can send your robot in and do the full walk around and gather, well, what was our progress today, even kind of thing, with nobody around to be in the way. Somewhere in there, you've got to figure out that this thing's probably expensive. And so what's your trade-off cost point on it? But we are seeing that there is one, obviously, and there's a case to be made from a financial perspective for at least some of these companies that this is a worthwhile investment for them, which is intriguing to me. Leon's got their newest. Yeah, these guys do a lot of really cool things with robots. If you've ever seen the one doing the parkour, it's quite fascinating. I got one last one. We're just going to watch a little bit of this clip. You can watch the rest of it on your own. But this is 1 year ago, and they're starting to roll some AI into Spot.
Greetings, good sirs. May I have the pleasure of knowing your names?
I'm Matt, and that's Vache.
A pleasure to meet you, Matt and Vacha. Shall we commence our journey? The charging stations where Spot robots rest and recharge is our first point of interest. Follow me, gentlemen. Let's proceed to the rock pile.
Hey, Spot, how do you like your job?
Ah, Mr. Matt, my employment as a tour guide provides great satisfaction. I find the dissemination of knowledge rather rewarding, don't you agree? Now behold the rock pile, a splendid collection of stone ensconced within wood boxes.
Hey, Spot, I love your accent.
Let us venture onward to the calibration board, shall we? Keep close. Why, thank you, Mr. Matt. My linguistics have been meticulously crafted to provide an authentic British experience. Now behold the calibration board, a marvel of black and white QR code tags.
My name is Matt Klingensmith. I am principal software engineer for Robot.
All right, so that one's kind of fun. Yeah, it has a little hat. If you the full thing is about 9 minutes long, and what they're working with is they've made it into a tour guide for their facility, and they're giving it different personalities through some AI programming. Now, the thing to recognize is it's not really reading off a script. He goes through into some detail there about what they've actually got it, how much they've given it. And certainly in terms of the personalities, it's really, he said, to change the personality, we change one line in our coding effectively, which is, this is the kind of personality you're going to have, and list it out. And then the AI takes it from there. So some of that back and forth was all being generated by the AI. You can start to think, oh my goodness, there's some really crazy stuff that we could do with some of this. And I guess, if you're putzing around in places like YouTube and stuff like that and seeing where the cutting edge guys are going with what they're doing with AI, it is really insane. In terms of this, how does it tie into IoT? Well, in this case, we're looking at, we've got a device that started off as just a robot and is now incorporating some of those things into it, where that's a very different level of autonomous behavior than we would see. You can imagine perhaps 5 years ago when they first introduced Spot, that you would have to program routes or things like that. So that, okay, here's where we need you to go around a job site. These are the things we need you to monitor and measure. We'll set these, if you've got these payloads attached to you, this is the data you should gather, kind of idea. And I think you can see where if we bring an AI into that, now all of a sudden the AI with awareness of, say, a footprint of a job site can start figuring out, okay, things that need to be monitored is A, B, and C, things that I need to check on at these intervals. Every night I need to look at this. Every week I need to look at this. Every month I need to look at this. And all of that can be run through realistically an AI type setup where you don't need a person to go ahead and actually program it all, right? So it's very cool.
The video I sent is actually showing their latest robot performing like mundane tasks in this factory setting. It's really cool.
Very cool. Yeah. Do I dare click the link?
It's a safe link.
Yeah, that's what they all say.
I know it's coming from me, but it's safe.
Hang on a sec. Let me. We'll take a quick look at this one too. Oh, I have to reset my stuff back. One sec. Oh yeah, this. Oh, I've heard of Atlas. Yes. Okay. And there you go. Fully autonomous robotics. All right. Yeah. The interesting thing about, I mean, I guess within that one, it's like, that's not very fast. And you think, oh, okay, what about the pacing of it? But again, within what you're doing there, which is you've got two effectively random locations to move stuff between. That's the kind of thing where yeah, you need a device that can work autonomously, because it doesn't know where the bins are going to be necessarily, right? As opposed to, say, an assembly line where you've got where your robots know exactly where stuff is going to be, and it's all very tightly controlled. Yeah, that probably, well, it would probably have more capacity than Spot did at 15 kilos. So yeah, there's just lots of interesting things out there that are kind of touching this space. One of the things to envision with some of this is there is a lot of back end stuff that's happening there. Now, I guess one of the ideas with something like that last robot with Atlas is that if he's autonomous, that means he could in fact work without a connection, and quite possibly you wouldn't, certainly not continuously, but even maybe not even all that periodically, pull data from him, and that would be, I guess, cool. One of the things that we see with a lot of the stuff, especially like with the Spot dog type robot, is that he's gathering a lot of data, but he's handing it off somewhere. So it's a cute physical structure in that it looks like a dog. We can put a hat on it and have it talk and stuff like that. Realistically, if it looked like a tank on treads, it would be just as effective, probably. That going up the stairs thing and going over a rock pile type stuff without falling over, and if it does fall over, being able to figure out how to get itself upright again, that's harder to do with tracks and treads. But yeah, we've got a device that has that mobility, can take whatever sensors we need on it to go gather whatever kind of, in that case, environmental information, structural information. It could be air quality monitors. It could be, things like that, checking temperatures as it goes around. Which depending upon what you're doing in your construction site actually can make a big difference. And you think about, there's actually IT jobs in construction companies that isn't just I'm looking after the computers for the front office people kind of idea. There is some really cool stuff out there. All right, I throw that out there to say this. There's tons of cool stuff. We'll do that a lot. There's just so much stuff to say, look at this, isn't this cool? Look at this, isn't this cool? Look at this, isn't this cool? So this will be a recurring theme for some of our time in here. I wanted to take a bit today to prep you for tomorrow, where we're going to do some build, and I want to show some of what I work in, and the reason I want to do that is because if I'm doing demonstrations or when I write my lab stuff, it's built for this particular environment. So we're going to build it in the lab tomorrow. You may also want to recreate it at home. We'll talk about how does that work in terms of moving stuff back and forth. But yeah, let me do that. I think if I go to this one, what do you see now? Oh, there we go. So this is actually a VM. And some of you will recognize it as it's a Linux VM. I have to ask, how is that to see at the moment?
It seems all right.
Okay, good. Occasionally in Teams, depending on what I'm doing, sometimes things look really fuzzy. So we're not particularly worried about seeing a bunch of detailed text today. So I'm not too panicked about it. But if you can't see what's going on, it becomes difficult. All right. So yeah, this is a VM. I've got my primary stuff is running in a VM, and I have a Raspberry Pi. So I'm actually running effectively 2 devices right now. And I could do more in terms of both. I could have more Raspberry Pis around. I do have more Raspberry Pis around, amazingly enough, somehow. I just haven't plugged them in at this moment. But even within what we're looking at here, this one box is going to become my private cloud, if you will, with all of the different services that I'm using on the backside to support my IoT implementation. Okay, what I'm going to show today is kind of our target for where we're trying to land at the end of the semester. Okay, so we will build towards this. We're going to set up a basic environment tomorrow. We're going to get basic connectivity working, but some of the stuff I'm going to show today is kind of like, this is where we're going to finish, not where we're going to start. So don't get too panicked. If you look at something and go, oh, I don't know how to do that. You're right, you don't. That's why we're having a course in it. This distro is its current release of Ubuntu. I believe it's 24 something or other. Okay, and to that, I've added a couple of tools. I've added in VS Code. I've added in Postman. I don't know if we'll use it much. We might play with it a little bit. And that's really it. Other than that, it's a pretty stock deployment of Ubuntu. I'm using VS Code to manage a bunch of my back end. Okay, just because it does it really nicely through one tool. So if I start that up, so one of the things we'll do tomorrow is we'll build this VM. So we'll build a Linux VM, install VS Code on it. One of the things I like to do, so I go to my folder structure, is under Documents, I've made a folder for my bits of code, and that's where I keep them. Okay, so different projects and things like that. I have also, in conjunction with that, I have affiliated this with, where is it? There we go. Oh, I got one open. With version control, so I am using Git for this, which means that my stuff all lives in a repository, and we'll work at setting that up. We will walk through over the next couple of weeks some of the tools around this stuff. I know most of you have seen Git before, but not really used it, would be my best guess on that. So we'll go down. We don't need to do a lot of things with it, but we'll do some fundamental stuff, because there's one thing that we do that does really well for us, which is this idea that if I've got this set up in the lab and I've got this set up at home, how do I keep my code synchronized? And Git is a brilliant way to do it, because all I do is make sure that the repository I've got sitting on GitHub has the current release. And then whenever I sit down, I just say, yeah, go pull the new one or pull the current one, and away I go. Okay, so let me go in here, and I think I'm going to go with this one, which is, I'm going to open this folder. How many of you have used VS Code before?
Everyone who has been in the Python course.
I think so. I hope so. Well, some of you, again, it depends when you did it. So But I think, is there anybody that hasn't seen this thing before? Okay, I'm not seeing any hands. That's good. Okay, good. Okay, so this is not a brand new tool for you. You've seen some things with it. We go into here. What's that? So I've just got some stuff in here. Some things that you might or may not notice is I've got a Docker Compose file in here. Now I know a bunch of you have used Docker before. Any quick question? Anybody not used Docker before? Okay. Anybody consider themselves an expert in Docker? I should stop asking questions that have no way to answer them, right? My guess is that you've used it a little bit. I know Carl does it with you, and at least you've touched it. We don't have to do a lot with it, which is good, but there are a couple of things, basic processes that will come up as we go through the course. I will add into Moodle some little bits around how to navigate Docker, a couple of quick articles that are short and get you through the stuff, and have a set of commands, the commonly used commands, which is really helpful. I would bookmark that for myself, keep it around somewhere. I don't print it out and put it in your notebook. Whatever works for you in terms of having it around. We aren't going to do frequently enough for the most part that you're going to remember all this stuff. It's not going to become part of your regular use. But again, it's one of those, when you want it, you need it. And so we'll have some resources, and I just keep tabs on where they are so you can access them quickly, and then you can get at some stuff. Because we will use Docker without necessarily going and building a big Docker space. So I've got some stuff in here. This is the stuff that is my backend. It's going to live in this virtual machine, and it's going to be effectively my private cloud. If I go ahead and build this, we just do a compose up. And I have now started 4 containers. Just like that. This is why we're using Docker here, because this is brilliant. Okay, I've got 4 containers up and running. They are running 4 different packages, 2 of which you might know about. The other ones we'll get to when we get to them. One of them is a database called InfluxDB. You probably don't know about InfluxDB, but you know what a database is. So this gives me a place where all of my data can go live. That's a big deal. We've also got a tool here called Grafana. So some of you I think have seen that before or heard of it before. It's effectively a dashboard building tool. So if we've got a bunch of data, how do we present it to users? And Grafana is a tool for doing that. So I've spun up a database. I've spun up a presenting tool. The other 2, Telegraph and Mosquito, are tools for moving data and transforming it from whatever format it's in to something that works well in our database. Okay, so we've effectively built a data path that when we see, again, as we walk through the course, we'll bring each one of these pieces into the mix one at a time and talk about, okay, what's it doing for us? Why do we have it? Why do we want it? What does it accomplish? So this is the whole thing running all at once. If I open a web browser, it's going to work for me. There we go. So Influx provides me with a web interface. Grafana provides me with a web interface. Okay, so that's a neat environment to try and work in. And if we go back to my VS Code, if I were to look at this YAML file here, let me pull it up. Come on, you. There we go. Okay, so again, this is one of the things we will build this together. So it's not, hey, go figure this out. We'll go through what all the little pieces are. Yeah, it's one of those pieces that down the road, if you're going to manage these backend environments, there's a few different pieces that fit in various ways around supporting DevOps and stuff like that. Where, you know, I mean, this is the stuff we're doing here. We're dealing with things like port numbers and network numbers and that kind of stuff. This is our space, right? In terms of ICT. So building up a set of containers and distributing them. That's one of the things that, like I said, we're treating this machine as a private cloud, which means effectively what we're really going to do is we're going to set up a system that could be distributed. If we wanted to, each one of these packages, so there are 4 packages we just started up, each one of them could run on a different box. Not only could each one run on a different box, that box could be located in an entirely different location. So the only thing that these 4 containers need is IP reachability between them. If they have that, they can live wherever you want them to live. The reason we might want to do that is, again, what we don't have here is we don't have my Raspberry Pi in here yet. The Raspberry Pi for us represents the sensing device. What we typically see in an IoT environment is we see lots of sensing devices. And then as we condense through this, very relatively few other components, like we might be trying to get everything into one database. Okay, or something like that. So at what point, how do we consolidate that? What do our data paths look like? And that's what Brian said, those other 2 pieces that the Mosquito and Telegraph are about, is how do we take this distributed architecture and bring it down to common resources, like a common database or something like that. Now, again, not surprisingly, you guys have done some stuff around clustering, say with Jeff's stuff and distribution. You didn't talk specifically about databases. You did it with virtualization, but the principles are quite similar in that I can have a distributed database. I can build clusters to support my databases, to make them more redundant, to make them more easily accessible across large geographic areas or through poor connectivity. There's lots of different things you could build in. Again, that's advanced stuff. We're not going to get there in one course. But yeah, if you look at if you're industry standard, large scale deploying stuff, there's a lot of these fancy techniques that can be applied into the IoT space. For us, we're going to live within one container, one virtual machine. We're going to try anyway. Let me just look. So right now, yeah. So I've just started up those 4 containers. Right now, this virtual machine is using 20 gigs of RAM. And it's not really doing anything yet. It's just running the 4 containers. So yeah, within our lab, this works fine. We have 32 gigs on those machines. So 20 to give over to the machine. I've got this in Windows is all you would need in the lab. I've got my Teams and other crap running here for presenting this. But this is, in terms of the lab, 32 gigs is lots. Now, some of you don't have 32 gigs at home. This runs fine in a lot less RAM. It will just be slower. Okay. That is a bonus. That's one of the benefits of using the containers, is we do save a lot of memory space with it. We used to build this as full-on machines, and it meant you were in tight to get all the virtual machines built on a single physical machine. Usually we distributed it through a couple. There's just a whole lot of benefits to running it in containers from Docker. Not the least of which is that for all 4 of those things, we can actually the containers are in a generic format, are published. We can just go get them. We don't need to run an installer on a database and figure out what all the little bits are. So for us and our use here, it's been absolutely brilliant to move this into a containerized environment, both from a resource usage perspective and from a can we deploy this quickly and easily perspective for things that we as ICT people aren't really that concerned about. Like most of us probably don't want to go learn, how do I actually take an installer for a database and make it all work? If you're thinking, oh, how hard can that be? Go try it. Yeah, it can be messy. So this is, as an environment, this is great. This is the reason why I'm working in Linux primarily here, is that Linux is just way better at dealing with Docker containers than Windows is. In theory, Windows should do it well, and it doesn't. Doesn't have nearly the installed base of users who are developing containers for it. Doesn't have nearly the set of stuff that you can run in it. And the environment just hasn't really got there. Some of the stuff works the same way, but a lot of it does not. In theory, there should be a way to get this stuff running, say, under Windows subsystem for Linux on your Windows box. But again, we're adding complexity to things that don't need it. So I'm running on a Linux VM and using VS Code, and it just works really slickly. So simplifying the whole process, this is the environment that I've settled into, and find it works really, really, really nicely. The other piece that I really like about this is there's this little blue button in the bottom. Open a remote window. And I'm going to do that. When I connect to a host, it's an SSH connection. Who are you? Where are we? I need an IP. I have forgotten it entirely. Because I was working with this and prepping all this stuff up, and I realized, oh my goodness, I have forgotten so much. Because this is not a big piece of my day-to-day job to go work with this stuff. I mean, I love it. This is, if I could go play with this stuff, this is the kind of stuff I want to go play with. But when you don't work with it every day, you guys know this. I can't type anymore either. There we go. It just goes away, right? Same thing happens to me too. So yeah, I'm working through a bunch of stuff here and going, oh, what is that command? Like with the Docker stuff, what is the command to do that again? All right. There we go. I need an IP address. 192.168.1.213. All right. So I'm connecting to, in this case, my Raspberry Pi. Ta-da. All right. So I've got a window here, which is a different window than, you see, I've got two VS Code windows going. One still has the stuff that's running in my VM. It's the stuff that is that backend stuff for Docker. So I'm using VS Code to run all my Docker file stuff. So my YAML files to do Docker Compose, all that. That's what's living in here in the back window right now. Okay, there's actually no Python or anything like that in there. It's config files, it's YAML files that Docker's going to interpret. This is a remote connection to my Raspberry Pi. Now I've been here already, and you can see this certainly looks like the file structure for Raspberry Pi, and I've already made a documents code, and I put a demo folder in there already. How about that? All right, with some code in it. All right, so I'm sitting, same desk, same tool, and I've connected off to my Raspberry Pi, which is sitting on the corner of my desk over here. Actually, let me do this. There we go. You can see it. I think you see it. Okay. And I can, yes. And there we have a very simple piece of code. The big piece of this piece of code, this is in Python, is this first line is I've got a library for the Sense Hat. Remember the Sense Hat? That's that little board we're going to use. So I've got a library for it. The library for the Sense Hat. This is such a popular thing with the Raspberry Pis that it's actually included with the Raspberry Pi OS. Like when you build the clean install of it, it's there. I didn't have to go pull this library down. It's already embedded in. It ships with the Raspberry Pi OS. All right. Real simple line then. So from that library, import the stuff. So it basically imports the whole set of library tools that are there. I instantiate it with sense equals sense hat. And then I've got a method called show message. Okay. And I'm going to run it. And the message I'm going to send is hello world. So let me run this and you'll see that. Well, you'll kind of see it's a little bright. That hello world scrolls across that LED display on my Sense Hat. Okay, so in the same way that I sent something from, so I'm remoted into my Raspberry Pi. I ran code on the Pi that actuated the LEDs. Okay, did a thing with the LEDs. Okay, I can flip that on its head. Instead of a show message, which is a routine for showing stuff on the screen, I could say, tell me what the temperature sensor is reading, or tell me what the pressure sensor is reading, or tell me what the gyroscope is reading. So this Sense Hat board has all these different sensor pieces on it. Tell me what's happening with the joystick, that kind of thing. Can all be done there. Okay, so I can write Python code for my Raspberry Pi. Within the course, we will be doing some coding. For the most part, I will give you the most of it. Yeah, that's probably the best way to put it. And then when we look at how we're assessing the lab work, you have a couple of options, one of which will be how much do you like coding? How much coding do you want to do? If you like coding and it's your thing and you're pretty good with it, you'll find there are ample opportunities to add into your Python code to get more things happening at this level, to do more data processing, there's a ton of stuff that can be done with the things that we're gathering here. Conversely, if you're like Charlene and don't enjoy coding, you can pretty much run with the code I give you and put your emphasis on a different aspect of your build. So I mentioned this a little bit last day, that when we work through the lab content, I'm going to give you a foundational piece, but where you take that and what you implement will be driven a lot by you. Okay. And within that means that if what you want to do involves a bunch of coding, you can go ahead and do that and get full marks for that. If what you want to do does not involve any additional coding of note at all, that's fine too. And you can get full marks going in that direction. All right. So we'll talk more about that when we look at specifically what we're accomplishing with those pieces. But please don't, even though we're living in a coding environment here, the amount of actual, I have to write new code stuff that you have to do can be really, really minimal. And none of it is from scratch. Okay. At no point will you get a blank screen and go, okay, I've got to write some code. It will not happen. Okay. And all of the basic functionality, I'll push code out at you. Right. Probably, I mean, the easiest way for me to do it is actually to put it in a repository and just let you pull from the repository, and then you get the current release of whatever the code is. All right. So there's all those bits that happen. Yeah. Even, let me get back to my other window here for a second. Even this, right? You're not going to type this big mess here. You're going to be given this with a couple notes in it, like, hey, you should change this thing to be what yours is. Okay. Like if I don't have one here, unfortunately. Oops. Ooh, I don't know what I did there, but that was bad. Let's not do that. Where's my other window? There we go. Nope. There we go. It's down here, hiding in the bottom of my screen. There we go. Okay, so don't let that scare you. There are a bunch of different avenues that you can develop stuff with as we go through the program here. Through the course here. So some of it, if you, like I said, if you want to do some stuff in Python, there is ample room for doing it. There is ample room for doing additional data gathering and using some of those other pieces. When we integrate them into the mix, like Telegraph, for example, is a data aggregating product, which means it can take data from all kinds of different, very diverse sources and port it in and transform it so that it can go into the database in a common format. That's what it's about. That's what it does. Okay, we're going to bring data in from 2 or 3 different devices. So a good way to put it, yeah. Okay, so we're gonna bring in data from the Pi, from the SenseHat piece. You can also bring in data from the Pi itself, if you want, and we're going to bring in data from our routers and switches. So we're actually going to have some of the data that they generate around things like just how many packets were this, how many packets were that, those numbers that we see in the show commands. Sometimes we can actually have the devices report them out and get them into our databases as well. Okay, so we're going to see 2 in the course, but again, that's a spot where, wait, I've got some other things that I want to see if I can make them part of this structure. So I'm going to figure out how do I set this up to bring in from other data sources? How do I make that convert in? Or perhaps, at the data level, once it's in the database, you're going, okay, I get whatever data there, but I really want to make it work nice. How do I keep my data clean? So some of those data analysis, data analysis techniques, both from ingestion, where you take in data and need to clean it, set it up properly, make sure it's of a consistent format, make sure it's sane. You don't have weird numbers in it because you've had technical glitches somewhere. How do you deal with those kinds of things? And then right out to how do you present that data to your end users? And that can be an emphasis for you as well. Is like, sure, yeah, we got a bunch of data, but I'm really going to emphasize on that last part, which is given some raw data, what is it I need my end users to glean from this, and what's the best way for me to present that to them? So we're building this whole long, big ecosystem out, and which pieces you want to emphasize will be up to you. I'm going to suggest to do reasonably well, you will need to emphasize at least one of them quite a bit. Okay, you can't just do bare bones in all 4 and go, hey, there we go. Although technically, if you do that, you actually will probably get a 50. So that's probably sufficient to get you through the course. My hope is that I mentioned last day, this can be a lot of fun. And it really can be if you grab hold of it and use your imagination a little bit and run with it. Charlene's been here before. Last year life happened and she didn't get to finish, so she's back. But she can tell you that you've seen some crazy stuff from people doing things, right? But you're just like, I can't believe you did that. Is that a true statement? You've seen weather stations, yes, yeah. Well, weather station.
A lot of weather stations.
Yeah, it turns out weather station is the lowest common denominator because you can just about do it in your. I guess, yeah. If you just take the bare bones stuff and need a way to present it, you'll build a weather station. And differentiating that is going to be hard. But yeah, if you're going, don't know what to do, don't know where to go, don't really want to do any work, then that you can if you don't do anything to the code that you're starting from that I've given, that's probably where you land, because it's really very little work to bring that up from there. Yes, you've seen weather stations. As have I. I should ban them. No weather stations this year. All right. That's what we're trying to build tomorrow. We're trying to get to the point where if we can sit in our Ubuntu VM with VS Code and load this piece of code onto the Pi and run it and have the SenseHat actually run that thing through, we have been totally successful. That's our target, for you to have this up and running tomorrow in the lab space. So again, please, if you need to bring your Pi, don't forget that. I will issue you a Sense hat for the course. If you need to, go put it in your bag right now. The other thing that you could think of, we'll take the first part of the class. People will start building the VM. I would recommend starting with a clean boot of the Raspberry Pi OS. That one is that I'm running right there. It's the current one. I will have equipment that we can set stuff up. If we need to format stuff tomorrow, either a USB stick or a SD card, I will have that functionality available in the room. But we can do it and get you set up if you don't come in with it. But know that I've only got 2 machines that'll do that. So there could be, there's not that many of us. There could be a lineup if you're trying to get a new card tomorrow. My recommendation is, again, USB 3 is the fastest boot device, followed by an SD card, followed by USB 2. All right, there we go. That is today. I will see you tomorrow at, what time are we on at? 2:30? For lab. ERB square.
Wait, tomorrow?
I'm last lab tomorrow. Yeah, tomorrow I'm last. 223 is last lab in the day. I just remember if it's 2 or 2:30.
I think I have something wrong with my schedule because I don't see a lab tomorrow into the tree.
You absolutely should. So that is an error. There is no 223 on Friday.
Let me check.
Hang on. Let me look. Am I messed up? One sec. Let me get my calendar. Tomorrow. Oh, shoot. Tomorrow is 225. Look at that. See, first week. 223 is on Friday.
Yeah, it is.
All right. If you're in my 225 class, I'll see you tomorrow afternoon at 2 o'clock. If you're in my 223 class again, I'll see you on Thursday back in this space. Okay, I got to go change what I'm doing tomorrow.